8 to 32, that'd be 40, right? But minus 1 is 39 for the broadcast, so that means the last usable is 38. So my broadcast is what? 172.31.6.39. So that's the DS one, the DS VLAN, distribution switches. All right, that leaves us with the access switches, also 3 nodes. So what's going to be my network starting there? My starting block? Anybody? 40 is correct. First usable will be what then? Actually, what's the subnet mask going to be? Same one, right? So 255.255.255.248. And so the first usable is 172.31. Okay, dot 6. Dot 40 is the network actually. First usable is 172.31.6.41. First usable. What's my last usable going to be? 46. 46, correct. 172.31.6.46. And what's my broadcast going to be in this case? 47. Okay, and that's going to be the access. That is the access switches VLAN number. So far, so good. Okay. Now we had a 1.0.0.0 for the WAN. We had 2 nodes because it's a point-to-point. 2 nodes. What's my subnet mask going to look like for 2 nodes? Anybody?
Oh, did you want that extra one also? Or?
No, not for that one. It's just a point-to-point. That's 2 nodes. It's right up. Yep, that's correct. I heard it. So 252 is correct. So 255, 255, 255, 252. That's going to be my subnet mask for the WAN. Network, of course, is 1.0.0.0. First usable is 1.0.0.1. Last usable is 1.0.0.2. And the broadcast is going to be 1.0.0.3. Boom. WAN. If you're still having difficulties with subnetting, I urge you to get on it. But we're not going to repeat it. We can't. We don't have time.
Can we use calculators?
Huh?
Can we use a calculator now that we're like into the...
I don't care. Here you can, but not on the exam.
Yeah, I know.
Here you can. Okay, does everybody have that nicely lined up? Got it all written out somewhere? All right, time to implement.
I have one problem. What was this first one? That was workstation. And this is the network for now.
So grab a laptop if you haven't done so. I haven't. I apologize. Grab a laptop, pop it somewhere. Label that terminal.
Yes, I didn't finish.
I don't want you to get us in bad habits.
Oh, that's it.
So terminal, grab a laptop and just label terminal. And then grab a console cable. Make sure you connect it to the RS-232 on the laptop. And we're going to start with the CR1. Everybody to the console on CR1, please. CR1. Now this is going to go pretty quick because this is basic crap. So this should be stuff we need to hit it. Okay? I mean, I might not be mean, right? Come on now. We've done this a lot, right? This should be no problem.
You go way too fast.
I am going way too fast?
Even before you did, yeah.
Huh?
You do. But I'm slow.
So am I going too fast? Let me know. I'll wait. Okay. And where are you at?
I'm just connecting.
Okay.
Smiley pants.
Let's go faster?
Let's get out of here. Let's see if we can break this down.
So,
oh my God.
Well, we could, but...
I'm done.
Huh? Ready?
Yep.
Well, the basic stuff.
Oh, yeah.
Yeah. All right, terminal. Everybody open up the terminal. If you get that little thing, continue with configuration dialog, you want to say no. Okay. So, enable. Configure terminal. I'm assuming if you don't ask me what this all means, you understand it. You should at this point because this is all basic stuff. Host name. And if you want to move ahead, by all means, CR1. Enable secret Cisco. Line console 0. Password Cisco login. All right, here's our first security thing. Ooh, all right. That's good. So normally at this point, I would implement Telnet. Now, that's what we've been always doing. Now, there's a problem with Telnet. Telnet is what? Telnet sends its password in clear text, as well as the information. So all the information that you would send with Telnet would be in clear text. All that means basically is that a hacker would just have to sit somewhere in the middle, intercept that message, and wouldn't even have to decrypt it. Just has to intercept it. Basically, that's all they would need to do. So you're making it pretty easy, actually, from a hacker standpoint. You know, stuff comes across, they use some kind of packet sniffer, they intercept the packet, and they don't even have to decrypt it. They basically can read it like it is. Okay? So obviously Telnet really, unless you're doing it internally. Now Telnet's not a bad thing to use if you're using it within your network, because it's not going outside. But if you're going from one network to another network, which we're going to do in this topology, then obviously it's going to go across what? It's going to go across a WAN. And anybody sitting on that WAN link, obviously, if they have the right tools, could intercept that Telnet session and hijack it. And when they hijack your Telnet session, basically they're in control of it, and then they can do anything they want. They can plant a so-called backdoor. A backdoor, basically, you wouldn't even know about it. They basically create a backdoor, and when you're not watching, they would actually gain access through the backdoor. So obviously, in the real world, you will never use Telnet unless you're using it locally inside of your VLAN or your LAN. If you're going across networks from one network to another network, it's always going to be what? SSH. So today we're talking about SSH. Now SSH stands for Secure Shell. So the S, Secure, SH, Shell, Secure Shell. The thing is, it's really, SSH actually can be used with multiple technologies. So Secure Shell actually rides on top of a technology. So it's not a standalone technology. I want to make sure we understand that. SSH by itself cannot be implemented. It's always implemented on top of another technology. In this case, Telnet over SSH. Does that make sense? So the technology that Telnet is riding on is Telnet, and SSH is riding on is Telnet. Does that make sense? Now we'll learn a lot of SSH implementations over other technologies. So again, it's very important to understand SSH by itself is not really a technology. I want to make sure we understand that. That's why I'm going to say it a few more times. SSH is not a standalone technology. It needs a base or foundation technology, such as Telnet, to basically ride on top of. So we're doing Telnet via SSH. Does that make sense? Okay.
So you're saying it's a secure shell, sort of like the Telnet's encapsulated within it?
Yes. Correct. That is good. Yep. You have, here's Telnet. Let's say this is Telnet, my fist right here, and Secure Shell basically encapsulates it. So the shell surrounds basically your Telnet session and protects it as it goes back and forth. Does that make sense? And only when it arrives at the other end, the shell is removed, and then you have the Telnet session. But while it travels from one point to another, it's protected by the Secure Shell, by SSH. Good? Okay. So the very first thing is we need to exit out back into global config mode to set this up. I'm doing it here because it's my preference. I can do this anywhere I want to. But usually, if you remember from our other classes, we also did every time after console, I did Telnet. So that's why I'm doing it here. I'm explaining it here because we always did Telnet here. Okay? So the first thing you got to do is you have to set up a domain that SSH is responsible for. Okay? So the SSH session can't be responsible for every domain in the world. So that means basically every company would have to have their own SSH session. Okay? So, your SSH session is not going to be my SSH session, and so on and so forth. in order to keep those sessions separated from each other, I must create a domain. Now, the domain usually is based on the company, so it's usually the company name. So if you're, let's say, Verizon, then your domain name is Verizon. If you were Microsoft, your domain name is Microsoft, usually. Not always, but usually. It's usually a common practice. If you're Cisco, your domain name is Cisco. Does that make sense? So, again, all that's saying is that SSH is responsible for that domain and not for anybody else, because you can't export SSH to other domains. They're only for a certain domain. And you have to, at the beginning, you have to make sure you identify that domain that SSH is responsible for. Does that make sense? I'm trying to break it down as simple as possible in terms.
So you just have to create a domain for the
They have to create a domain for it. Okay? So, everybody ready to go? So the command for that is IP space domain hyphen name. So IP space domain hyphen or dash name. Okay? Can everybody see that a little bit? Okay? That's the command. And let's keep it simple so we don't have to remember thousands of things. Let's just call it Cisco since we're in a Cisco class. Okay? So lowercase Cisco. That's the domain. That's the name itself. So our SSH session that we're about to create is responsible for Cisco. Not for Microsoft. It's case sensitive. The domain name is case sensitive. So it's responsible for Cisco, but not for Microsoft. So our SSH session wouldn't work for Microsoft or for Verizon or for Granite or for any other company. It's responsible for Cisco. Do you have some questions? 'Cause I know you were like waving.
No, I'm looking for some.
Are you good?
Well, yes, for the most part. I'm
What's-
done with this. I am having wiring issues.
Okay. Which one?
Well, bottom part.
Why, the red or something?
No, it's just not right. The switch to like the PC is wrong or something. Remember?
Yeah.
Well, I'm gonna need that in a minute, right?
Yeah.
It's just not right. Remember?
You can hit enter, by the way.
Well, I'll fix that. I can't see what it is.
Okay. You don't.
I'm stressed.
You stressed?
Yeah, it's been a stressful day today.
Just calm. Stay calm.
I'm calm.
That's good. All right. So, in addition to domain, you need a specific username password combination for SSH. This will not be the password that you use for Telnet, because you can actually have SSH and Telnet installed in the same environment. Telnet for internally, SSH for externally. So they both will have their own passwords. But where Telnet, if you remember, only needs a password, we always use Cisco, if you remember, SSH requires a username and a password. And that is done also at the global config mode. Okay? Now you could do it before the domain name. I always do it afterwards. So that's a preference. It doesn't matter which of the two you do first or last. But since we're in global, I'm going to do it here. So the command is user name. Okay, so username. You're going to use your first initial of your first name. So in my case, it's Robert R. And your complete last name, all lowercase. So R more for me. And you use your first initial and your last name. That's going to be your username. I think everybody can remember that.
All case sensitive?
Just for the class, it's also case sensitive. So keep it lowercase. I mean, in the real world, you would not do that. That would be, plain craziness, because that's what they would try to guess immediately. Oh, it's probably using his first initial and last name. But we don't want to get confused here in the class. It's confusing enough. We're going to keep it simple. That's the only reason I'm doing this. So this is not good security practice. This is a security class. So I want to overemphasize that. You don't want to use your username that's something that's common that they could guess. Does that make sense? We're doing it only for the environment. Space, password. Again, we're going to stick with Cisco only. Again, that's not good practice either. Normally you would do something different, but we want to make sure that we don't forget or can't remember.
So it's all one
One line, yep. Username, space, your username, space, password, space, Cisco. Okay. Again, this is specific to SSH, will not work for the Telnet session. This is for the SSH session. Does that make sense? Okay, hit enter. All right, the next thing is we're going to set up now the crypto port. Crypto stands for the encryption technology. Cisco prefers something known as RSA. RSA. Don't ask me to pronounce it because it's 3 letters, RSA. It is the 3 developers who created the technology. They're all Indian. I will slaughter the names. There's last names. Those are the initials of their last names. RSA are the initials of the last names of the creators that created the technology. They decided, let's use our last names. Okay, 3 guys, 3 last names. It's called RSA. The cool thing about it is they all are graduated from MIT, and they actually, when they graduated from MIT, they decided to open the headquarters where? In beautiful Boston, Massachusetts. So RSA, as the company is called, is a Boston, Massachusetts company. It's a security company. And you probably used their RSA tokens at one point in your careers. Today. Well, look at that. All right, so we're using the software version of it. There's a hard token version. You have a little like key.
We used to use the hard. Now
Yeah,
we use the
hard.
soft.
Now you use the soft. We're using the soft too on this on the routers as well as switches. Routers and switches both use the soft. All right, so we're going to do that now. We're going to use the RSA encryption technology. That's what Cisco prefers. There's tons of other ones out there. This is not the only one that exists, but that's the one that Cisco prefers.
Why?
Because they believe it to be the best. There's white papers on it, of course, that say that the others are better, and they fight each other. Everybody claims to be the best. But Cisco, in the end, decided that RSA, for their type of equipment, serves it best, based on baseline tests and so on and so forth. That's the only reason. They have come to they did a lot of testing, and they said this one actually was the most secure. Okay? The command is crypto, space, key, space, generate. Oops. Helps if I spell it right. And then RSA. So crypto, key, generate, RSA. You hit enter. Now when you hit enter, hopefully, you'll get this name for the key will be CR1, because we're on CR1. That stands for CoreRouter1.Cisco, which is the domain name we put in earlier. Remember that? .Cisco. It says on the bottom, and it tells you that also choose the size of the key module in the range of 360 to 2048 for your general purpose key. Choosing a key module greater than 512